Okay, we'll look at, it's called sine law. So we have a triangle here, and we're trying to figure out how to solve it. One of the key pieces is sine law is a law of trigonometry that can be used on any type of triangle. So have you learned primary trig ratios? You ever heard of those?
I've heard of
So sometimes they'll show this, which aren't, they kind of relate to this, but I might as well put them in here. Let's show something like this. Sine theta is equal to opposite over hypotenuse. They call them like sometimes SOHCAHTOA.
Yeah.
Yeah,
So good. Yeah.
SOHCAHTOA. Okay. And tan theta opposite over adjacent. These are nice, but these are shortcuts and only work on right angle triangles. Sine law and cosine law being the other major one that we use can work on any triangle. So if you remember anything, this one is far more powerful to remember than these ones. These are more like shortcuts, okay? So we have a triangle here. We don't quite know the internal angles, all three yet. We can sort that out pretty quickly. But I need to write down what sine law is. And sine law is a set of ratios. So sine A divided by side A is equal to sine B divided by side B is equal to sine C over side C. This can be flipped. It can look like this, A over sine A. We use uppercase to represent the angle here, and this is the side length. Is equal to side B is equal to side C, all divided by sine of the angle. And when you name a triangle, you just have to make sure that the angle and the side are opposite. So for instance, if I call this angle A, that makes this lowercase a, just because it's opposite of that side. If I say this is B, this would be side B. And if I say this is C, then down here is side C, okay? In order to make sine law work, you need to have a complete ratio. So in other words, you need to have something like all of the A's, or all of the B's, or all of the C's. You don't need to set up three. You only need to set up what you're working with and the complete ratio that half. So sometimes a good place to start is to literally just set up the ratio, whichever way you want to memorize it. Angles on tops or angles on the bottom is fine. And then from there, plug things in. If you have three pieces, you can always find the fourth, okay? But you have to have a complete ratio. If you happen to have like side A, angle B, side C, that doesn't work because we don't have a complete ratio, even though we do have 3 points of the triangle. We'd have to use a different law. So we're going to take a look at this one here. We'll name some of the stuff we've got. We're going to call side C 10 units. We didn't give it anything particular, but I'm going to plug these into this formula up here. So I'm going to rewrite it. Sine, okay, A over A is equal to sine B over B is equal to sine C over C. So we'll do some little highlighting here. We have side C, we're going to replace with 10. Okay, because we've got that is equal to 10. We have angle B is equal to 110. Angle B is 110. And we have angle A happens to be 30. Great. We have three pieces of information, but do I have a complete ratio?
No.
I don't. So from what I just told you, I can't use sine law. Is there anything else you think we might be able to do to get a missing value?
We can find the angle for
C. We can find angle C. Knowing that we have a small trick that the internal angles of a triangle are always added up to 180, I can take 180 and subtract these two values. So I'm going to subtract 110, and we're going to subtract 30 from it. So actually, horizontally writing this might be a little nicer than vertically. 180 subtract 110 subtract 30 is going to end up with, this will call this angle C. Angle C is equal to that. So if angle C is equal to that, that means this is 70 minus 30 is 40. Is that correct? Yeah, that looks right. So this is 40 degrees, which means our angle C, go to my highlighter here. I'll remove this back. I'll never find it again. It's going to be 40. So now we have the complete ratio. So we'll actually go about the process of plugging this stuff in, and then we can decide what we want to use. Sine A we said was 30. So we got 30 degrees. Side is still unknown. Sine angle B is 110. Side is still unknown. And sine angle C is 40, and side C happens to be 10. It's still a division, so we'll put that over. Okay, so we have a complete ratio, which is super important. We really can't do sine law without this. So we have this. Now the question becomes, what are they asking us? Well, in this question, I still have two unknowns, A or B. So we get to choose. Since it wasn't explicitly written in this question, what would you like to solve for? Side A or side B?
A.
A. Great. Instead of trying to have three ratios side by side, I'm just going to drop this middle ratio out. And that way we're just working with two. And the algebra becomes much easier to work with. So when we do that, we're going to set them equal. We're going to drop off this middle one and put a little x here. So we have sine 30 divided by A is equal to sine 40 divided by 10. Now, I could punch in sine 30 into a calculator and get some value. Sine 40 in a calculator, get some value. But it's going to be a decimal, and it's going to be an approximation. So I'm actually going to wait to do all that at the end. I'm going to manipulate the algebra, and then at the very end, punch everything into like a scientific calculator or a graphing calculator. The goal here is to find side A. So we are going to isolate. Do I have a new color here? Yeah, I do. Perfect. Isolate for my A. Okay. We have two fractions that are equal to each other, so we can use this common property known as cross multiplying. Really what we're doing, it's like a shortcut. We're multiplying both sides by A, okay? And we're multiplying both sides by 10, okay? And what happens here is these 10s create a 1, these A's create a 1. So it ends up being 10 times sine 30, sine 40 times A, which looks like cross multiplying, okay? But we're applying two movements or two actions at once. That's what cross multiplying really is. So we have 10 times sine 30. I'm still going to write it like that so I don't have to write this long decimal. And I have sine 40 times A. I'll write it at the back here. Again, the goal is to get A by itself. So to get A by itself, I need to divide. I need to divide both sides by sine 40. When I do that, these ones create a 1, commonly called canceling out. And whatever I do to one side, I have to do to the other. So I've done it over here too. So now I'm left with A is equal to 10 multiplied by whatever sine 30 is divided by whatever sine 40 is. And sine is an equation. It's a series actually. And what you're saying is I'm putting the number 40 into some equation here, like almost like function notation. Sine is a function. And it's going to pump out a number. Instead of me calculating this, it's going to go do it ourselves because it's a complex series. It takes a really long time to calculate. Let's see if I can't. Can I get it? Here we go. This will be a good one we can build off of. We'll use Desmos Scientific Calculator. Yes, that's what I'd like. Good. Move it here. What did we say we had? We have 10 times sine 30 divided by sine 40. So I can set this all up. Division, so I'm making a fraction. 10 times sine 30. And you see how they put those brackets around? That's like saying I'm going to put 30 into the function 40, sine and 40 as a value. Give us a number right away. I could have said, what's sine 30? Oh, nice one. What's sine 40? There we go. That's an example of an unruly number. And then I could have decided, okay, I'm going to do 10 times this answer here. Well, allow me to copy. Oh my gosh, that's not what I wanted. Didn't copy. 0.5 is a nice one that works out. Divided by. Technically, this still works. And then I could have pumped in this answer here, I think. There we go. And we got something pretty similar. In fact, it ends up being the exact same because I used an exact value here. But I would have never written this number to so many decimal places. I would have done some rounding and I would have been a little bit off. So it's nice if you can put this all into the calculator as one thing, and it will do the best job of not rounding before your final answer. So in this case, we've got 7.7, or we'll say 7.8 if we're doing length of a side maybe. So A ends up being 7.8 units, okay? And if we wanted to, zoom in one more time, we could have done this exact same thing and dropped this ratio off, and we put these two ratios together to solve for side B, and I could do that over here. But it's the exact same process. We do a little bit of cross multiplying, and then we isolate for B, and it would give us some other set of units. So it's just a duplication of what we've done.